2023, question 7. First of the long questions. Olga is a cyclist. The diagram below shows a road which is not drawn to scale. AC is horizontal and BC is vertical. So the right angle triangle, the right angle is given. And we're given BC and AB. The gradient of the road, written as a percentage. Find the gradient of AB, correct to the nearest percent. And we're told the gradient of the road is BC over AC. We need to know rise over run, given to us in 2023. I don't know what's going on with this paper, but it seems a bit strange. So we just need to find AC, the square root of 70 squared minus 9 squared. If you know your Pythagoras, and that's 64.92. So we end up with BC over AC, 9 over 64.92 as a percentage. This question you may expect on the junior cert. I'm not sure about leaving cert. 12.96% to the nearest percent, 13%. Olga wants to measure the height of a hill. The point H is the top of the hill. So we're just dealing with 3D trig here, triangles. In this triangle we only have the angle 17, so we can't find, we'll call this X just to keep it simple. We do have 3 angles in this triangle, so we could use, and we have a side, we could use the sine rule here to find this side over here. So we're going to have the sine of 87 over RO is equal to the sine of this angle over 20. So let's just find 87 and 88, 87 and 88, 160 and 15, 175, so just a small little angle here, 5. Sine of 5 over 20. So 20 sine 87, put in degrees if you want, is equal to sine 5 by RO. So if we just leave the RO there and divide by sine 5, we'll get what RO is, and this works out to be 20 sine 87 divided by sine 5. 229.16. I'll leave it to 2 decimals for now because we want to find X. So now we have this 229.16 in a right angle triangle. We're looking for opposite. We have adjacent, so the tan of 17 is equal to O over A, X over 229.16. So X is equal to 229.16 by the tan of 17. Correct to the nearest meter, it's given 70.06 on a calculator, so X is equal to 70 meters. Nice easy intro to this question. Olga has now done some tests to measure her lung capacity. When she's resting, the volume of air in her lungs after t seconds is given by this. Okay, so let's just get the max and min straight away here. It looks like we're going to need it. 2, we're going to get the max is going to be 2 minus 0.4 by minus 1, so 2 plus 0.4. And the min will be 2 minus 0.4. So 2.4 and 1.6, that's this line here, 2.4, 1.6, and part A is you're asked to find A and B, so A is the min, A is 1.6, B is 2.4. Part D, what's the connection between V prime T and the derivative of V and whether Olga is breathing in or breathing out? So let's have a look here. When she's breathing in, she's going to have more oxygen in her lungs. And when she's breathing out, she's going to have less oxygen in her lungs. So in is more, out is less. So if V prime T is greater than 0, it means it's going in, it's going up, air is going in. And if V prime T is less than 0, we're talking about going out. So I think that's what they're looking for here, the in and out for the derivative. Then we're asked to use the formula to find each of the following. Firstly, the volume of air half a second after t is equal to 0. Well, that's a strange way to phrase that. So why don't they just tell us t is equal to a half or 0.5? So we're just subbing in here. We're going to get 2 minus 0.4 by the cos of pi over 2 times 1 over 2, which is 2 minus 0.4 by the cos of pi over 4, which is 45 degrees if you want to change it and not use radians. And this is giving me 1.717 correct to 3 decimal places. Then we're asked to find rate, so we're looking at v prime t. So when we differentiate cos, we're going to go cos goes to minus sign, so this will become plus. So we're going to get v prime t will be equal to 0.4 by the sine of pi over 2 t, and then differentiate the angle, and you're going to get pi over 2. And this is find the rate half a second, so this is again when t v of a half, v prime a half. So we put that in here, we're going to get 0.4 pi divided by 2, if we bring these two together, times the sine of pi over 2 by 1 over 2, so sine of 45 again. So 0.2 pi, if you want to simplify it, 0.2 pi by the sine of 45 will give us our answer for this one. 0.2 pi by the sine of 45, let's give me all fours here, 0.444. And I won't put the units in, you can put them in yourself. Olga's breathing is also measured when she's doing gentle exercise. During this time when she breathes in fully, so we have a max, and when she breathes out fully we have a min. She breathes in twice as many times per minute, so we're going to have a different curve here when she is resting. So use this formula to find out all of these values here. Okay, let's just go back up to the top for a second. She breathes out twice as much as she breathes in. Instead of the max being at 2, it's going to be at 1. And instead of this being at 4, it's going to be at 2. So it looks like this graph. It's going to be 1, 2, 3, 4. 5 will be max. 6 will be min. 7 will be max. 8 will be min. Just do it to there. So it looks like it's going to go something like this. So it looks like it's going to go something like that. So instead of pi over 2t, we're going to have just pi t. We're going to have to multiply that by 2. So that's definitely the angle. And then the difference between the max and min, if we look back at this to help us, actually, the 2 is the midpoint of these two here. So we need the max and min, and the midline, we have the angle. So the max, min, and midline, we have the angle. The max is 3.6. The min is 1.3, 4.9 divided by 2 is the midline, so 2.45. So to get up to 3.6, we'd have to add 1.15 and multiply it by the cos of pi t. And we'd have 2.45. To get to 1.3, we'd have to take away 1.15 cos pi t. So one of these is fully correct, and it's going to be this one here, because we can add 1.15 with the maximum value of cos being plus or minus 1, and we can take them away. So I think it's this one here, 2.45 plus 1.15 cos pi t is my answer here. I think that's all they're looking for. Yep.